This is the last part of section 10.1. This is the easiest part. I saved the best for last. It's called restricted domains. And so a rational expression is a fraction. So just like all fractions, if the denominator is equivalent to 0, then the fraction is undefined. So denominators of rational expressions cannot equal 0. This creates what is known as a restricted domain, or you might hear domain restrictions, however you want to say that, or excluded values. I've also seen it called excluded values. So any value of x that makes the denominator equal 0 cannot be part of the domain. So let's look at this first example. We have f of x, which again is another way of saying y, equals 5x squared minus 3 over x minus 1. We don't really care what's on the numerator. We can plug in whatever number we want for x on the numerator. It's the denominator we have to focus on. So whatever expression is on the denominator, in this case it's x minus 1, cannot equal 0. I just put an equal sign with a slash through it. If you were from there to solve for x, by using the same skills we've used before, we would find out that x cannot equal 1. Because if x equals 1, the denominator equals 0. So that is your domain restriction. The domain is all real numbers not equal to 1. So that symbol is a capital letter R with 2 bars, all real numbers. So any number you can think of, but not 1. That is your domain for that function. Let's look at the second one. F of x equals x squared minus 2x minus 15 over 7x minus 2. The numerator can be whatever it wants. It's the denominator that cannot equal 0. So 7x minus 2 cannot equal 0. We'll add 2 to both sides. We're going to solve this just like an equation. Divide by 7. So x cannot equal 2 over 7. That is the restriction. Another way of saying that is all real numbers not equal to 2 over 7. So that's the one domain restriction. That is your domain. So this is pretty easy. Just remember it's all about the denominator. The denominator cannot equal 0. So let's look at the next one. Pretty simple. It will say state the restricted domain. So it's whatever's on the denominator cannot equal 0. And these are generally pretty easy to solve for x. X cannot equal negative 3. So the domain is all real numbers not equal to negative 3. One more time with example 4, nice and simple. Whatever's on the denominator, 8x plus 3, cannot equal 0. We'll solve. We can divide by 8. So x cannot equal negative 3 over 8, which means the domain is all real numbers not equal to 3 over 8. I'm sorry, negative 3 over 8. Sometimes you have a trinomial on the denominator, or something that needs to be factored. So x squared minus 2x minus 15, we need to factor. So this is 7x minus 2, and then that factors, this one's a little easier to factor, into x minus 5 and x plus 3. So you actually have 2 restrictions. X minus 5 cannot equal 0, and x plus 3 cannot equal 0. So if I solve each one of those, x cannot equal 5, and x cannot equal negative 3. So there's 2 restrictions for that one. And you'd have all real numbers not equal to negative 3 comma 5, and you would just list them out. I don't know if it has to go least to greatest on your homework. I don't think it cares, but mathematically speaking, we like to list things least to greatest. And last but not least, example 6, f of x equals 8x minus 3 over x squared minus 5x plus 6. Again, we have a trinomial on the denominator, so we're going to need to factor. So that's 8x minus 3. That is going to factor into x minus 3 and x minus 2. So again, that gives us two restrictions. Which are x cannot equal 3 and x cannot equal 2. So our domain would be all real numbers not equal to 2 or 3. And I'm not sure which way the homework asks for it. It either asks for the restrictions or it asks you to state the domain. So it would be all the real numbers you can think of, but not 2 or 3. So this is, I think this is the first part of the homework for section 10.1, but I always save it till the end because it's just easier to follow once we've done all the factoring practice. But that's it for that last little bit of section 10.1.